elementary matrix. First, let us see the definition for elementary matrix. Elementary matrix is a matrix obtained from an identity matrix by performing only one elementary transformation. Now we'll see some examples. So this is an identity matrix of order 3. Perform only one elementary transformation. Second row is obtained by multiplying the elements of the second row by 3. So first row there is no change. 1, 0, 0. Elements of the second row you multiply by 3. So 0 into 3, 0. 1 into 3, 3. 0 into 3, 0. Third row there is no change. So we have performed only one elementary transformation. You are getting this matrix from identity matrix. So this is what is known as an elementary matrix. Another example. So this is also an identity matrix of order 3. Here first row is replaced by multiplying the elements of the second row with 5 and adding to the elements of the first row. So second row you multiply by 5. 0 into 5. 0. 1 plus 0. 1. 1 into 5. 5. 0 plus 5. 5. Now 0 into 5. 0. 0 plus 0. 0. So first row is replaced by performing one elementary transformation. Second row there is no change. 0, 1, 0, 0, 1, 0. Third row also there is no change. 0, 0, 1, 0, 0, 1. This matrix we are getting from this by performing only one elementary transformation. So this is also an elementary matrix. One more example. So this is also an identity matrix of order 3. Here third row and second row we are interchanging. So we are performing only one elementary transformation. First row there is no change. 1, 0, 0. Third row and second row you interchange. Third row you write it as the second row. Second row you write it as the third row. So we are performing only one elementary transformation and we are getting this from an identity matrix. So this is also elementary matrix. So elementary matrix is a matrix obtained from an identity matrix by performing only one elementary transformation. You have seen the definition of elementary matrix. Now let us see the application of elementary matrix. Here there is a 3 by 3 square matrix. Do one elementary transformation on this square matrix. Elements of the second row you add elements of the third row after multiplying by lambda. So first row there is no change. Second row is obtained by adding elements of the third row after multiplying by lambda. So this you multiply by lambda and add to this. So A21 plus lambda times this. Similarly, so the next one A22 plus lambda times A32. A23 plus lambda times A33. Third row there is no change. Now you do the same elementary transformation on an identity matrix. So you will get like this. So this matrix we are getting from this by doing only one elementary transformation. So this is an elementary matrix. Now same matrix you pre-multiply by this elementary matrix. So you will get this. When we see these two, they are same. That means doing elementary transformation is same as pre-multiplying the given matrix by an elementary matrix. From these two we can come to the conclusion like this. Doing an elementary transformation on a matrix is same as pre-multiplying the matrix by an elementary matrix. Here we have seen row transformation. For a row transformation, we are pre-multiplying the given matrix by an elementary matrix. For column transformation, we have to post multiply the given matrix by a elementary matrix. Every non-singular matrix can be transformed to an identity matrix by a sequence of elementary row operations. So this is a theorem. Here there is an illustration. A is a non-singular matrix. Its determinant is 11. So it is non-singular. So it can be transformed to an identity matrix by a sequence of elementary row operations. In an identity matrix, here it should be 1. So necessary elementary operation is this R1 should be replaced by multiplying by 1 by 2 all the elements of the first row. Instead of doing this elementary row operation, we can pre-multiply by a elementary matrix. So now this is a identity matrix. Same elementary operation, you do it on this identity matrix. So now first row is replaced by multiplying the elements of the first row by 1 by 2. So 1 is to be multiplied by 1 by 2, so 1 by 2. 0 into 1 by 2 is 0. Then second row as it is. So this is an elementary matrix. Because we are getting this from identity matrix by only one elementary row operation. Now the given matrix is to be pre-multiplied by this elementary matrix. For this elementary matrix, let us give the name E1. So the given matrix is A, that is to be pre-multiplied by this elementary matrix. So E1A. So you multiply this half into 2, it is 1 plus 0 into 3, 0. So it will be 1. Next elements of this row, you multiply by the elements of this column and add. So you will get this. Similarly, multiply these two matrix by multiplying by corresponding row with the corresponding columns and adding. You will get like this. After multiplying these two matrices, you will get like this. Next, for making it a identity matrix, below 1, here it should be 0. So necessary elementary row operation is this. Elements of the second row is to be replaced by adding to the elements of the second row elements of the first row after multiplying by minus 3. Same operation you do it on an identity matrix. So you will get this. This is an elementary matrix. So it is E2. We are getting this from identity matrix by single row transformation. So this is an elementary matrix. Then this E1A, this matrix, is to be pre-multiplied by E2. So E2 is an elementary matrix. So now you multiply these two matrices. This is E1A, then this is E2. If you multiply this, you will get like this. If you multiply these two matrices, you will get like this. 1 into 1, 1 plus 0 into 0, 0. So this will be 1. Like that you complete this multiplication. To transform the given matrix to identity matrix, here we have to make it 1. To make that 1, this is the elementary transformation needed. Second row is replaced by multiplying by 2 by 11. So now instead of doing this elementary transformation, we can multiply by this elementary matrix. So same elementary row operation, you do it on a identity matrix. So what you are getting is a elementary matrix. So this matrix is to be pre-multiplied by this matrix. This matrix is given the name E3. So this is to be pre-multiplied by E3. This E3 is this matrix. Then already we got this. Then multiply these two matrices. So you will get like this. So 1 into 1, 1 plus 0 into 0, 0, 1 plus 0 is 1. Next you multiply the elements of this row by this column and add, you will get this. Then similarly you multiply the elements of this row by the elements of this column and add, you will get this. And this you multiply by this and add, you will get this. So complete the multiplication of these two matrices, you will get like this. Now to make it identity matrix, here we want 0. So necessary elementary row operation is this one. So here we have to make it 0. So elements of the first row is obtained by adding elements of the second row after multiplying by 1 by 2. Same elementary row operation you do it on a identity matrix. What you are getting is called elementary matrix. For that you give the name E4. E4. Pre-multiply this matrix by E4. The E4 is this matrix. You multiply this matrix by this one. Pre-multiply. So when we multiply these two matrices, you will get like this. Multiply elements of this row by the elements of this column and add, you will get 1. Then elements of this row you multiply by the elements of this column and add, you will get 0. Similarly complete the multiplication of this matrix. So you will get an identity matrix. So a given non-singular matrix by a series of elementary transformation, we converted it into a identity matrix. So from this is clear, every non-singular matrix can be transformed to an identity matrix by a sequence of elementary row operations.